Hi, everyone. Thanks for joining today. Welcome to today's webinar on the ticket to reducing formulation steps. I'm Robert Grotans, the Global Technical Marketing Manager at X-Rite, and I'll be moderating today's webinar. Presenting today is Tony Boylan, one of our Senior Application Engineers. A few things to go over just before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. During the webinar, if you have any questions, please use the questions function on the GoToWebinar panel. I'll be monitoring the questions, and at the end of the webinar, we'll have time for a short Q&A session. Finally, this webinar will be recorded, and you will receive a link so that you can review the webinar at your convenience. With that, I'll turn it over to Tony to kick things off.
Hey, thanks for everybody for attending. Just to give you a quick background on me. I'm an expert in computer color matching formulation, mainly in the paints, plastics, pigments. I have been at X-Rite for 20 years, actually, this year, and I've been doing this for 25 years. So what this webinar is about, it's very generic on how does computer color matching formulation work, what are some of the advantages that we can see, and what are some of the pitfalls, and just go through a process of how you actually are doing it. All right, so here's the agenda. We're going to go through the advantages of computer color matching, how does it work, how good results you get, which is the important stuff, some of the pitfalls, and like Robert said at the end, we'll go through a quick question and answer session. Any questions are fine. We'll go through them. I've heard pretty much anything you can possibly hear. First of all, we're going to have a poll, and we're going to do this periodically through this. So the first poll is, are you currently using X-Rite software to do color formulation? So we're going to leave this poll open for about 30 minutes so you can go ahead and answer through the poll. Okay. All right, some of the advantages. One of the advantages for a computer color matching system is you're able to hit the targets faster. So you can actually save on time. So really what this is doing is, anytime you're spending money to get a color computer system, you want to have a good return on investment. So how long does it take me to do this? Depending on how many hits it's taking you now to do a color match, and that's generally based on your visual, your guesswork. What we're going to try to do is cut down on the amount of hits. So you can actually calculate the recipe using the colorants and the dyes you have on hand. So whatever formulation system you're using, we'll actually go in and characterize each one of your pigments. Your resin systems can have multiple resin systems, and then the computer can help you generate recipes. You take the guesswork out of how much pigment loading to achieve a certain opacity or transmission. This is a big selling feature for this, because most of the time when you're trying to figure out opacity, you over-guesstimate how much of a pigment loading you need. So say, for example, I might need a pigment loading of 3% to make it opaque for certain colors. A lot of people will guesstimate 10%. They want to make sure it's opaque when they produce it. The computer color matching system can help you figure out the loading for different colors and can show you, okay, for a red, I might need to be 6%. That's going to save you a lot of time, cost savings on products, on pigments, where you don't have to guesstimate. Like I said, most people over-guesstimate what they're doing. So number 2 poll is, how many hits does it take you to achieve a match? So this is what we're saying is a visually acceptable match.
Just to jump in quickly, it looks like a lot of you are saying it currently takes 4 or more hits to achieve a match.
Okay, how does this actually all work? The first thing is, this is all math. Okay, so what we're actually going to do is we're going to characterize your colorants in the software. So we're going to make samples depending on what type of system you have, whether it be paint, plastics, inks. If you want to try to figure out what the opacity should be, we're going to put it on some type of a contrast card, which is like a black and a white card. Or if we're doing plastics, we can actually measure the sample in reflectance and then measure through the sample, transmission. So X-Rite would help you specify what samples actually need to be made, what different concentrations you need to be made, getting information from you. And then we would actually characterize that mathematically by reading those into the software. All right, so we're using math. So the more math points you have, the bigger the gamut of the colors that you can achieve. A gamut, really in its very simplistic form, is the size and color space of all the colors that you can actually achieve with your pigment system. So the more bigger gamut you have, the more pigments you characterize, the more colors you'll be able to match. For example, in a retail paint store, they generally have 12 to 15 colorants that they use. And so they have a fairly wide gamut of matches. Really depends on your process, depends on your pigment supplier, but we're trying to get as many pigments as we possibly can. And the computer would tell you or help you figure out which pigments to use to achieve a certain match. How does it work? Well, in the software, we're actually going to go in and we're going to make different letdowns, mixtures in your resin system, whatever your white calibrating is pigment, your black calibrating pigment, and then we're going to use each one of your colors like red oxide, yellow oxide. We're going to make samples. We're then going to read those samples into the system and then tell the computer what is in each sample. So when we tell the computer what is in each sample, what we're actually doing is we're characterizing different concentrations. So mathematically, I can see, okay, if I have a little bit of yellow oxide, how does it react? If I have a medium, a lot of red oxide, how does it react? We're also going to read those in on some type of a contrast ratio card, a black and a white. So I can show, okay, at this different concentration, what's the opacity? That's going to help us when we formulate to say, all right, I want to make this opaque. And the computer's going to go in and say, well, here's the recipe, and here's how much pigment you need to achieve opacity and match the color. All that goes back to what we're doing here. So however good the data is here is going to correspond to how good we get data out. And X-Rite, we walk you through this. We teach you how to do it. So we don't just leave you on your own. And we'll actually train you and help you evaluate what you're actually doing. Now, once you characterize it, then we can go into the software and we can say, all right, here's my standard. Here's the pigments I want to use. Here's the resin I want you to try to achieve. It goes in and it says, all right, here's all the matches. It can actually help you find multiple matches based on an initial recipe. So you could pick the one you want, or you could have the software pick the best match for what it finds. So you're actually taking the guesswork out of it. So we use your knowledge of what you're doing now, and we're going to try to cut down on the amount of hits you do. However good the data is when we input it into the color file is how good the matches will be. So how good results? Okay? What I keep saying is garbage in, garbage out. So garbage in means I'm not controlling what I'm actually doing in my process. And so if I don't control that when I load in the color file, then the math, and it's just math, is not going to give me good data. But we help you look at your process to try to figure out where we can minimize any type of process variation. A correction recipe. Now, Robert said you're saying about 4 hits. What we consider to be a very, very good system is 1 hit and 1 correction. So the computer gives me an initial recipe. I go make it. I come back. I read in that trial. So I tell the computer, this is what this recipe actually looks like, and it gives me a correction. We can actually minimize that by storing into the system what that actual color looks like and tie it to a recipe. So I can store that into a database. So later on, when I start making matches, I can actually use that data mathematically to help me get a better first shot. So we can actually make the system smarter. Again, software is good as your original pigment calibration data. When we load in the samples into the colorant file, it's going to backfit to itself. So it's actually going to go in and say, all right, I have this much red oxide, this much resin. Here's what the sample looks like. It'll then mathematically match that and comes back and says, well, theoretically, you're this far away overall. So it's going to show you what your process variation is. Time saving make multiple hits is greatly diminished. Like I said, we're generally trying to get it to one shot, one correction. So if you just save 2 hits every time you make a match, you're saving in company costs as far as personnel, pigment product, resin product. So the return on investment on this is extremely huge. All right, poll 3. Who in your company specifies what constitutes an acceptable match? It could be a customer, it could be internally. All right, some of the common pitfalls. Variations in colorant batches need to be controlled and tested. This includes your incoming raw material. If you're making your own pigments, it's extremely important that you check each batch to batch. If you go from a pigment supplier, they are generally giving you some type of sheet that says, this is how far we're off batch to batch, whether it be on the actual color, whether it be on the strength. And so each one of those need to be controlled when it comes in, okay? Whether your resin's the same, however you're doing stuff, we need to actually get that data. And the software can help you track that data. Got to have a scale. Got to have a good scale. A 1 decimal scale, 0.0, is not a good scale. The minimal is a 0.00 scale, a 2 decimal scale. The more you can go out, so the smaller your batches are, the more you need to have like a 2 or 3 decimal scale. That's extremely important, whether it be in production or in the laboratory, that we're accurately putting in the system inside the recipe what we're telling the computer we're doing. Sample thickness. Since we are specifying that the computer should give us a loading level of pigment to achieve a certain opacity, we have to be very important on what the sample thickness is, because the sample thickness is going to affect what the color is and what the opacity is. So when we're loading in colorants, we're going to tell the system, all right, for each sample, this is the opacity that we're doing based on this film thickness. So we'll actually input the film thickness. When we formulate, we also can specify this is the film thickness we want to try to achieve a match. So you can have different film thicknesses. In the actual characterization of the pigments, we want to have the same film thickness. Now, you don't have to be perfect. You can actually measure the film thickness for every sample and input that. Any type of problems that you have in your film, whether it be a paint, a plastic, an ink, we want to try to be as precise as possible in what we're doing. Any type of effects that have surface conditions where I got scratches on it, I don't have a good mixture of what I'm doing, we need to control that. Again, garbage in equals garbage out. Your entire production needs to be reproducible. A lot of times when we go out to places, the lab is very good as far as reproducing what they're doing every time, but then they take it out to production and it's not as good as the lab. In production, they're not taking the time to actually go in and measure accurately or put things in accurately because they're trying to save time. But if we save time by hitting recipes and saving time on not having to do as many corrections, going into production, we can actually help this system get better faster, but they have to be precise in what they're doing. One thing you can't do, since this is math, you just can't lie to it. You just got to tell the computer what you're actually doing. Training of staff. This is a big thing that we do. We help you and we train your staff. We actually take the administrator of the system and we will teach you to be the trainer. So you'll be the one, we'll be training the trainer. We can help you set it up. We can look at your process variations. Most of the guys who are doing this have over a decade of experience. So we've seen pretty much any problem you could possibly have, and we can give you good recommendations on how to do stuff. All right, just a quick summary. Color computers can help you actually save time and money. Like I said, we have a lot of customers who do a return on investment study, and you usually get your return on investment in just months, not years, because you're saving in pigment cost, you're saving in personnel cost, because the system's going to be more accurate. You're not having to guesstimate. Guesswork can be taken out. This was not replacing a good color matcher. This is helping a good color matcher get better. This is helping somebody who might be just starting in color matching get up to speed much more quickly. All right, so it's a tool to help you. Experts, you can actually make people become much better, much quicker. Like I said, you got to have some knowledge, because you got to know what your products are doing, what your pigments are doing in your resin system. But a color computer can actually help you take a lot of the guesswork out of it. What we're trying to do is just cut down on the amount of time it takes to get an acceptable match, no matter who specifies what that match criteria is. All right, we're going to do a quick question and answer session. Right here on the screen, this is how you can contact X-Rite. If you have any questions after the webinar, you can certainly go to our website. You can call in tech support, and we'll get you to the right person. Robert?
Thank you, Tony. Yep, so we have a few questions already. If you have a question you'd like to ask, feel free to submit them. So the first question we have is, can sample thickness of drawdowns be used to help calculate a recipe for different film thickness?
Yes, so two things to that. When you load in your color file, we can tell the computer what the thickness is of each individual sample. So let's say it's 20 mils. When we formulate, we can tell the computer, okay, I want to make this sample and I want it to be opaque at 30 mils. So that's where the system is calculating not only the color it wants to achieve, but the opacity. So it's going to give me a loading level to try to achieve that opacity at the different film thicknesses. You can actually also specify, so you don't have to type it in at runtime. I could go through and say, 20 mils, 30 mils, and just have my operator pick 20, 30. It could be a different molding for plastics. It could be if you're doing spray outs for paint, how many sprays you do. But certainly you can pick different thicknesses.
Along that same question, how do you measure sample thickness?
Generally, what you're going to use is a micrometer. We don't sell micrometers, but on any scientific website you can get it. You're measuring the thickness of a substrate that you're putting down, and then the ink film, paint film, or you're measuring the thickness of the plastic chip. It's just a micrometer. It can give it to you in inches, in mils, in millimeters. They're widely acceptable out there. They've been used for years.
So someone is working with dyeing textiles. Is the software able to make corrections for dyeing these?
Yep. It's very similar. You would pick whatever type substrate you're using. In this case, cotton, wool, poly blend, and we're going to characterize our dyes mathematically. Same thing we're doing with paint, plastics, inks, and then same thing. You characterize them, then you get a formulation. You read in the trial, it'll give you a correction. The math is slightly different in the textile arena, but the software is going to look exactly the same. And we have experts who have been working for 30 years in the textile industry as far as formulations.
Does the software only work with Lunetta cards, or can other substrates be used? If so, do you have any recommendations?
Any type of contrast ratio card is fine. Lunetta is just the biggest brand name out there. But any type of contrast ratio card works, if you're using plastics, we'd actually have an instrument that can measure reflectance and then measure transmission. So instead of doing an overlight over dark, I do a reflectance transmission. But any contrast ratio card is fine.
Is the drawdown method the best method for gauging color in opaque paint matching?
I would assume what you mean is, can I do it wet or can I do it drawdown dry? Generally, we want to do it a drawdown and let it dry because it might change colors as it goes through the drying process or curing process. But generally, it's much better to do it that way consistently. Now, when you're drawing down, one thing you got to worry about is if I do by hand, if I'm going to be very consistent on the ink film or paint film because of the pressure different people do and the speed. You can also purchase, not from us, but from other scientific companies, mechanical drawdown bars, mechanical drawdown systems. But we can help you specify and look at your process and try to figure out the best way to do it.
Are there any attributes to look for when selecting a substrate to input the data?
Yeah, I mean, it depends on what you're actually doing and what your process is. For example, if I'm printing and I'm printing on absorbent substrates, I'm going to have some type of absorbent substrate, whether it be a black and a white card. Generally, in the paint realm, in most ink films, you're going to put a coated contrast ratio card. So the pigment and the resin is not absorbing into the card. It's sitting on the top of the card of the coating. That way you're very consistent on what you're doing. But like I said, we can help look at your process and help you specify exactly what type of substrate you need.
We'll take a few more questions. Can I measure colors on clear substrates if the ink laid down is a little translucent?
You can. What you would do is, on the system, we would back it with some type of a white. On most of the handheld instruments we would have to put it on some type of a big white tile. If you're doing on a benchtop instrument, it has a white backing on it. But the substrate can be clear. If you're on a spherical instrument, it can be metallized. Again, what we'll do is we'll look at your process and we'll help you specify exactly what substrate and what instrument you need to be able to measure these. But you certainly can do it.
Should resins that have different opacity be entered as 100% drawdown, or should they also have gray shades?
In the mass system that we have, which is called a multiflux mass system, we're going to pick our calibrating resin. So that's what we're going to make all our mixtures in. We also can have alternate resins. Alternate resins means I can use these same pigments, but it's a different resin than the calculating resin, the calibrating resin. We would make 100% of that resin, and then generally we're going to have a couple mixes of white, a couple mixes of black, and then a couple grays. So you're generally going to have 6 to 7 samples, but one sample would be 100%. The good thing about this mass system is I don't have to make a colorant file for every resin. I can put those resins as alternate resins, and when I formulate, I'm going to pick which resin I want. Also, if the pigment has any type of opacity difference, you have some resins that are more opaque than others, we characterize that. We either read that in overlight over dark, reflective transmission. So when I pick certain resins, the loading level can change to achieve a certain opacity based on the resin's opacity. So all that's calculated.
Another question about measuring transparent materials. Would this system work with materials such as stains used on kitchen cabinets in liquid form?
It will. It works better. I mean, we do have different types of instruments where we can measure stains and we can back it with something in a liquid form. The issue with that is when you put it on the wood, the cabinet, it's going to absorb into the cabinet. So it's going to change what the look is. versus a liquid. You can measure it liquid, but you'd have to have a liquid standard. In a cabinet, and we do have multiple systems where people are doing this for stains, since you have wood grain in the wood, it absorbs differently depending on how well you sand the cabinet and all that. We're generally going to take an average measurement. So we're going to measure a spot multiple times and move it. So if I had a piece of wood, I would stain it, just like I do on a black and a white card, stain it, and then I'm going to measure multiple times on there so I can take an average. But you could measure in liquid form depending on the type of instrument that you have. But you'd have to have a stain standard in liquid form.
I'm going to take one more question for today. If we didn't get to your question, we will follow up. I'll write all these down and I can send them to Tony. But the last question is, I use a spectrophotometer to measure fabric samples from mills that are producing fabric for us. I measure them to our color standard, but if the mills do not have color measuring software, what is the best way to communicate with them the direction of where the shade needs to go?
If they don't have computer software and they don't understand computer knowledge as far as LABs, delta LABs, all that, you have to tell them in words. So it has to be redder, greener, yellower, bluer, lighter, darker. What they need 100% if they're doing it by visual is they need to have some type of controlled lighting. So they need to have a light box so they can see what you're seeing mathematically from a visual standpoint. But you just have to use words. If they don't understand what the LABs are, one thing about the textile industry is since a lot of your textile companies are leaving the U.S. and are overseas, some of your big specifiers are specifying everything electronically. So they're not actually seeing physical samples. Everything's electronic. So you really need to have some type of a color computer. And if you're in a supply chain, a lot of your specifiers are specifying that you have it to have a certain color system. Because one thing you're doing visually, it's very subjective. Some people can see things differently. And if you don't have controlled lighting, you can certainly see things differently. Remember, all we're doing in color is energy interaction. So if I don't have a controlled energy, I don't have a controlled color.
Perfect. So we got a ton of other questions. We don't have any more time today to go through all of these, but I will, again, write them all down, and we can have someone follow up with you on your specific question. You'll also receive a recording to this webinar. So once again, I'd just like to say thanks to all of you that joined, and have a great rest of your day.
Thanks, everybody.